Section 1.5, Video 4. In this video, we're going to continue to use Venn diagrams to solve survey problems with three sets. Example 6. 100 students were surveyed about their favorite Winter Olympic sports to watch. Of those surveyed, 68 watched curling, 35 watched freestyle skiing and ice hockey, 32 watched curling and ice hockey, 38 watched curling and freestyle skiing, 17 watched curling and freestyle skiing but not ice hockey, 38 did not watch ice hockey, and 2 did not watch any of the Winter Olympic sports. Since this is written in a paragraph form, I'm going to summarize it over here to the side with little bullet points to maybe make it easier to make sure that we've used each one of our statements. Since I'm trying to make it in shorthand notation, I'm going to let C represent the sport curling. I'm going to let F represent freestyle skiing. And I'm going to let I represent ice hockey. "100 students were surveyed." That's going to be my first bullet point, 100 surveyed. The next bullet point says 68 watched curling. So 68 is going to have the C for curling. 35 watched freestyle skiing and ice hockey. Make sure we use the word "and" because a statement with "and" is different than a statement with "or." F and I. 32 watched curling and ice hockey. So 32 for curling and ice hockey. 38 watched curling and freestyle skiing. 17 watched curling and freestyle skiing, but not ice hockey. So let's write that down. 17 curling and freestyle skiing and not ice hockey. So I'll abbreviate the ice hockey with the I again. 38 did not watch ice hockey. So 38 is not the ice hockey. 2 did not watch any of the sports. So I'm going to say that as not curling and not freestyle skiing and not ice hockey. Let's start our Venn diagram. As you went through those statements, you probably noticed there are three main sports being discussed. The first one that was listed was curling, so I'll make a set for curling. I'll make a set for freestyle skiing. And a set for ice hockey. Let's start going through our statements and try to find something we can use. I actually am noticing two statements that are very specific about all three sports. The 17 for curling and freestyling, but not ice hockey. And also this one, 2, which is not curling, not freestyle skiing, and not ice hockey. Either one of those would be a very good place to start because they're specific about all three sets. And so we should be able to put them in one space of our Venn diagram. 17, like curling and freestyle skiing and not ice hockey. So inside the curling set and inside the freestyle skiing set. And I'm going to use my hand to hide the ice hockey set to say not ice hockey. So we want where curling and freestyle skiing overlap, but away from the ice hockey set, the 17 would go in that single space. And I'm going to check off that I used that statement. And I'm going to move the hand out of the way so we can move on to the next statement. The last one, 2 people did not watch curling, they did not watch freestyle skiing, and they did not watch ice hockey. You might know already that that is going to go outside all three sets, but we could also use our hand to hide the curling spaces, to hide the freestyle skiing spaces, and also to hide the ice hockey spaces. And so those 2 people would go in the 1 space that's not covered. And again, we can move our hands and check off that that statement was used. Let's try to go to another statement. Let me try this 38 does not like ice hockey. If I hide the ice hockey set, then I need to figure out how the 38 is separated in these other spaces. There's 4 spaces that are still being shown. But because I have 2 empty spaces that aren't filled in yet, I'm not sure how to separate the 38 among all 4 of those spaces. It's still unknown. We'll save that statement for a little later. Let me go and try to be specific with 2 sets at a time. Let's look at 38 people watch curling and freestyle skiing. So curling is here on the left, freestyle skiing is this set on the right, and they overlap in this center football shape. So together, that needs to add up to be 38, but 17 are already listed in that space. We're going to take 38 total and subtract the 17 from one of those spaces, and notice that we're going to get 21 to fill in that center. So together we would end up with 38 where curling and freestyle skiing overlap. And we can check off that statement. Let's try to find another statement that is very specific about 2 sets. 32 people like curling and ice hockey. Find where curling set and ice hockey set overlap, and that would be these 2 spaces. They have to total 32. Okay. However, remember 21 is already listed. We're going to take our 32 total and subtract the 21 that's already shown, and we would end up with 11 that goes in that space. And we can check that one off. Let's continue with another statement that is specific about 2 sets. 35 people like field hockey and, like freestyle skiing and ice hockey. Looking where freestyle skiing overlaps with ice hockey, and we get these 2 spaces, and that needs to total 35, but again 21 is already listed in the center. Let's take our 35 total and subtract the 21, and you should get 14 in the space to complete that overlap of freestyle skiing and ice hockey. And we can check off that statement. Now we can keep going. We have 68 that like curling. Notice that inside the curling set there are 4 spaces, but 3 out of the 4 are filled in. So we should have enough information to now finish that last space. We're going to take the whole 68 total and subtract the people that are already counted. 17 and 21 and 11 were already counted. And in doing that, I end up with 19. And that completes the curling set. I don't think we have enough information to try the 100 people surveyed because we still have too many unknown spaces, but there's another statement down here we hadn't used yet. 38 do not like ice hockey. Let's take our hand and hide the ice hockey set. So anything hidden, we're not going to add up, but all the other spaces, the 19, the 17, and the 2 are part of not liking ice hockey. We're going to take our 38 total and subtract the spaces we already know. We already know 19, we already know 17, and we already know 2 were counted. When I work on that subtraction, I end up with 0. Now my hint to you would be make sure you write in the 0 because you calculated that and you know for sure that no one is in that space. Don't leave it blank because blank would indicate that you're not sure what that amount is yet. and we know that that amount should be 0. And we can check off that statement. Now we can move that hand out of the way and go back to that last part, the last statement that we haven't used. 100 were surveyed. We can either add up all the people that are already counted and have one subtraction, or we could start out with 100 and then subtract them individually. In the previous question, that's what I did, is I subtracted them individually. Let's go ahead and use a parenthesis and combine them all together. When I combine all of the people that are already listed in our Venn diagram, I end up with 84. So this subtraction becomes 100 minus the 84 that's already listed in our Venn diagram, leaving 16 for the space that's empty. And now our Venn diagram totals 100 people from the survey. Once our Venn diagram is complete, we can use it to start to answer some of the questions. Part A, how many students watched ice hockey? I'm going to highlight the ice hockey set in yellow. And so everything inside that ice hockey set of yellow is going to be counted. That would be the 11, the 21, the 14, and the 16. Adding all that together would be 62 students. Part B, how many students watched ice hockey and freestyle skiing, but not curling? When I see but not curling, that means I'm going to hide that curling set. So if I hide the curling set, and all the numbers in the curling set, remember I want to say yes to ice hockey and yes to freestyle skiing. So I want to find where ice hockey and freestyle skiing overlap, and that would be here. But again, we're avoiding the numbers that are hidden in curling, so that would be just the 14 in this one space. And I can move that hand out of the way. Part C, how many students watched curling but not freestyle skiing? So yes, inside the curling set, but I'm going to hide the freestyle skiing set. So inside the curling set would be 19 and 11, but hiding anything in the freestyle skiing set, so 19 and 11 would end up being 30. Part D, how many students watched curling or ice hockey? So or indicates our inclusive or. They can be inside the curling set or inside the ice hockey set or where they overlap. So anything inside any of the yellow. Anywhere inside ice hockey, also anywhere inside of curling or where they overlap. That would give us 19, 17, 11, 21, 14, and 16. And adding that up, I get a total of 98 students. And that ends question 6.